Hi, everyone. I'm going to talk about a for fun research project that I've been working on since October. And I've never presented any of this publicly before. So Ray, I was just talking yesterday about, or a couple days ago, about research that was presented at Rochester for the first time. So here is some. I've never talked about this publicly. And I also was not aware that I was going to be giving an impromptu talk. And so I was kind of working on putting these slides together just in the interims between talks today. So here it is. It's just mineral names, a DEI perspective. And I want to say none of this will be my perspective. I'm going to inject as little of my own perspective and opinion into this as possible. I'm just going to present numbers and information. And hopefully that information will give you a new perspective. And this is something I haven't done alone. Going through all the mineral names was a ton of work. I did most of them. I did have some help at the end from one of my collaborators, but I've had a tremendous amount of intellectual support from Gabriella Farfan at the Smithsonian, Tyler Spano at Oak Ridge National Lab, Mike Rumsey at the British Museum, and my friend Marco Bermanec at University of Bern. So naming minerals has been something that's been talked about by mineralogists for as long as we've wanted to talk about minerals. And that's created, of course, a great mess in the historical literature with what do we call these things? They don't come with names. Nature makes them. We pick them up. We want to talk about them. So we give them names. And historically, mineralogists have had a great variety of opinions on how to name minerals, what we should name minerals, what is a mineral that deserves a name compared to one that's not. Now we have the International Mineralogical Association since 1958 that thankfully makes a lot of those decisions for us. But some people have had some really strong opinions on this over the years. And one that I found particularly interesting was one by the chemist Richard Genevieve, who in 1811 published over 100 plus page essay just detailing his thoughts on the state of mineralogy. And he includes a bit of a diatribe on mineral names. And there's a very interesting section of this. So he says the sources which are less fitted for deriving the name of a mineral from are to be found in its history of the geographical situation. So he includes labradorite in this, the nature of the country. So sort of just the climate or type of area. So here says like meadow or whatnot. And then the names of persons, provided they are the names of those who discovered the mineral and made known its properties and habits. And so he gives prehnite and witherite, which are the first two minerals that we know of that were named after people. So prehnite was named after Hendrik von Prehn in 1788, and witherite was named just a year later in 1789. And then another one I personally think is funny on here, and John Rackavan will also appreciate this, some feature in the history of the mineral, apatite, which of course is derived from Greek of deceiver, because apatite was easily mistaken for other minerals. And apparently our opinions as a community have changed, because since 1978, the number of minerals named after people has surpassed the number of minerals named after any other type of namesake. And I went through and I categorized all these namesakes, and I tried to get them into groups that were useful, but also as large as possible. So I didn't have a million little individual groups. And so that gave me a sizable other column, or a sizable other name group that I feel pretty comfortable with. But other ones, so I had person, place, a property, so either a physical or a chemical property. I was also keeping track of indigenous groups just as a matter of curiosity, and then other, which includes like organizations, ones like apatite, where it's not like essentially an intrinsic property of the mineral, but it's more of like a historical aspect of that mineral's discovery or recognition. And one more thing on here. So I also went through and categorize all the unique name roots as well, so that I could actually fish out so that there aren't 12 different arohatites that are counted. So there are almost 5,000 unique name roots. And so there are a lot fewer reused roots than you might think, even though we easily think of like fluorapatite, chlorapatite, hydroxylapatite. There are really only around 1,000 reused name roots. And so what does this look like over time? So our tastes have definitely changed in what we're naming minerals after. And naming a mineral after a person became the most popular in the early 1900s. And then, like I said, in 1978, that surpassed all of the other namesake types combined. And there are also upticks. We started naming minerals more after places as well in the sort of the second half of the 20th century. And there's also an uptick in minerals that are named for their properties, especially their chemical properties, around the advent of the electron microprobe, which was a huge watershed moment in the description of extremely small things. And for this project, I was really most interested in the people that have minerals named after them. And so just a experiment. What does a random sample of minerals that are named after people look like? And thankfully, you can go and do this using the random mineral function on mindat.org. And Mindat, again, was extremely instrumental in being able to find all of this namesake information, because not a lot of it is easily and quickly accessible. So I went through and I hit the random mineral button until I landed on enough minerals that were named after people that had pictures, or that I could find a picture of, to fill a screen. And this is what that looked like. And as you may recognize some of these people, at least one of them is in attendance here with us, Peter Tarasov. And again, I'm not going to inject any of my own perspective here. Minerals are named after the people that are involved with them. And many of these individuals have contributed tremendously to the field. Peter Tarasov, again, just I brought him up. The Dean of Mont Saint Hilaire contributed tremendously to our understanding of this very historic and important locality. Clifford Frondel, legendary mineralogist. So minerals are named after the people that are involved with them. But what else does this entirely random selection of people have in common? Like if you were playing Guess Who, and these were the people, would you be able to win? Would this be an easy or a very difficult game of Guess Who? And again, this is not, I didn't skip over individual people. This is a selection. I kept going. I ended up going through around 50 or 60 minerals. And these were the ones that showed up. And this is why. So the gold line are the unique male namesakes. So unique men that had minerals named after them, and then unique women that had minerals named after them are the blue line. And there are over 2,400 unique male namesakes and only around 135 unique female namesakes. And then I also just, again, for curiosity's sake, just plotted when people that had minerals named after them, who were alive when the mineral was named after them, when they lived. And I was actually surprised by this result, because I thought that there would be more people than ever that were currently alive had minerals named after them, but that's not the case. It seems like we peaked in about 1954 with the number of living namesakes. Again, I only looked at, for that bar graph, for that background, people that were alive when their mineral was named. And again, you can also see a growth when we started naming significantly more minerals with the advent of the electron microprobe. And that's also when more minerals started being named after women. And so using the information from the bar graph, I looked at the mean age of people when they were honored. So all of the namesakes, and then only scientists. And so the average age of a man that was alive when they were honored with a mineral was 55.72 years. And the average age of a female who is alive when they were honored with a mineral was 61.26 years. And among scientists, men were around 56.79 years old when they were honored with a mineral, and women were around 64.77 years old when they were honored with a mineral. And if we look at who is naming minerals after people, who's naming them after men versus women, Russia has the most minerals named after women and the second most minerals named after people. Approximately 1 in 6 minerals that were named after a Russian were named after a woman. 5 of the 6 were named after men. In the USA, 1 in 27 minerals that were named for a person were named after a woman out of more than 450 minerals. In Germany, that ratio is 1 in 49, with almost 250 minerals being named. The highest ratio is Argentina, although the N is small. So almost 1 in 3 minerals that were named after an Argentinian are named after a woman. And the remaining 2 out of the 3 are named after a man. And after the top 5 or so, the N for female namesakes decreases significantly, which was part of the issue when I wanted to dig more deeply into the data to see when the naming was happened, is there just are not data to work with. So a plot of people this is again just information from people that were alive when the mineral was named after them. You can see the plot gets really, really dense again with the advent of the electron microprobe and the founding of the International Mineralogical Association. And you can see also that there are very few minerals that are named after women prior to around 1950. So the first 2 named for women were named actually in the same year, just by chance, 1866. So Laurite was named for Laura Joy, who is the wife of chemist Charles Arad Joy, who was the friend of the mineralogist that described Laurite. You can draw any sort of connections you like there. And the other one that was described that year was named by the mineralogist von Rath after his wife, Maria von Rath. And then there were no minerals named for women for over 60 years, or just under 60 years, until in 1924, Skłodowskite was named for Marie Skłodowska-Curie, Skłodowska being her maiden name. And after that, again, a pause until the 1950s, and then things started to pick up. And if we just look at scientists, we see there are a lot of younger scientists. Back in the day, career progression was certainly different. But if we just look at 1958 onward, I just picked that as the founding of the IMA, and to try to cut off this earlier historical data, and to also just get a more fair comparison between the men and women with minerals being named for them. The average age of a male scientist post-1958 was 59.45. The average age of a female scientist with a mineral named after them, again, all alive when the minerals were named, was 64.06 years. And we can look at trends over time. So on the subplot on the bottom is the female to male ratio, with 1 being an equal ratio. So 50-50 split between male and female namesakes. And this is year by year female to male ratios. And this is a little bit messy. And so I did a 25-year moving average to smooth that line out, which is blown up now here. And when I had fewer data, I could run a number of different regressions on this. And I tried to just do a sort of farcical estimate of how many minerals we would need to get to an even male to female ratio using those regressions. And once I had finally filled in the rest of the data, the other regressions no longer worked. The second order polynomial dove right down into the x-axis, and so I couldn't use that anymore. I also did a logistic regression, which is like an S-shaped curve, and that one also just was asymptotic. And so we're just left with a really simple linear regression. And I also did a regression on the number of minerals that were named, just to, again, this is a basically farcical number. 44,000 minerals would be required for us to discover by the year 2248 if we follow the current track to get to parity. However, it's estimated that there are only around 10,000 or so minerals left on Earth, 10,000 or so minerals on Earth, so a few thousand more to find. Potentially there could be more, especially if we are able to improve our technology and look at extremely, extremely small things, the nano phases, and if those can make it past the IMA, because that's really all it takes to become minerals to make it past the IMA. So really, what this is saying, of course, this is a truly farcical number, but it would be essentially impossible following the current trends. And part of the reason is that the actual female to male ratio is shallowing out. And so this is a logistic regression. So like I said, it was asymptotic. And so it wasn't exactly informative for getting to an equal female to male ratio. But you can see that the growth in the female to male ratio is actually slowed down. And we appear to be approaching some sort of ceiling around 0.2, which is 1 in 10. So for now, that seems to be the limit unless we can change our perspectives. So thanks again. I just wanted to say these are numbers, and I'll gladly discuss these numbers with anyone who's interested. So thanks. And I think I'm the last one, so we can all join each other in the social lounge.